Hi everyone, this is Fahad Mirza and I welcome you to my channel. In this video, we are going to have a look at a new project from Amazon Science called as RAGChecker. RAG means Retrieval Augmented Generation, and RAG allows you to give LLM a chance to provide you more grounded response in the context of your own data. RAGChecker is a tool designed to evaluate how well the models can understand and respond to questions using external knowledge sources. This is known as a retrieval augmented generation pipeline, and RAGChecker helps identify strengths and weaknesses in these models, which can lead to more accurate and informative responses. RAGChecker works by breaking down the evaluation into smaller parts, looking at both the retrieval and generation process. We will be installing this RAGChecker locally, and then I will be showing you how you can use it on some sort of input data from the RAG pipeline. RAGChecker checks how well the system retrieves relevant information and how well it generates responses based on that information. This is done by extracting specific claims from the response and ground truth answer and checking them against other texts. RAGChecker provides a detailed analysis of the system's performance, including overall metrics, as you can see on your screen, diagnostic retriever metrics, and diagnostic generator metrics. This helps researchers and developers identify areas for improvement and develop more effective RAG system. Just have a quick look at these matrices because they are quite important. Let me give you a very quick overview of these matrices before I move forward. So if you look here, there are few mentioned. If we start from the left, there are overall matrices like precision and recall. Precision means the proportion of correct claims in a model's response. Recall is a proportion of correct claims in the ground truth answer that are also in the model's response, whereas F1 score is the harmonic average of precision and recall, providing a balanced measure of overall performance. Then we have a retriever and a generator matrix here. Again, we have claim recall and context precision. Context precision is a proportion of retrieved chunks that contain at least one ground truth claims. And then you can see that there are a lot of other matrices around faithfulness, which is the proportion of claims in model's response that are entailed in the retrieved chunks, indicates how faithful the generator is to the provided context. And then noise sensitivity is quite important because it is the proportion of incorrect claims in the model's response, which indicates the generator's sensitivity to noise coupled with useful information. And then hallucinations are a huge problem with RAG pipelines. If you have ever deployed it in the production environment, you must have known that hallucination is quite a big problem. That is where this can help you by telling you the proportion of incorrect claims in the model's response that are not entailed in any retrieved chunk, indicating the generator's tendency to produce unfounded claims. And then there are a lot of other things which you can check out on their GitHub repo, and I will drop the link to it in video's description. But as long as you understand these matrices which I have just explained, you should be able to get some meaningful response out of this RAGChecker, and looks quite a good thing because I believe we have a lot of tools out there, but we don't have much governance around them. But tools like this RAGChecker can help us to diagnose and identify a lot of RAG issues. Okay, now let's try to get it installed and then we will see how it works. So I'm using this Ubuntu system and I have one GPU card, NVIDIA RTX A6000. I will be using OpenAI's models with it. You can use Hugging Face hosted one or with Light LLM or I think Amazon Bedrock, but I'm just going to go the simple way, the OpenAI's way. I don't see any option of using it with Olam or anything else. And to be honest, I think for this one, for RAG checking and all the judging, you should be using some API based models like from Anthropic or from OpenAI or through Bedrock. And this is my GPU card, as I said. I won't be using it as much because I will be using hosted one, but this GPU card and this VM has been very graciously sponsored by our good friends at Mast Compute. If you are looking to rent a GPU or VM on a very affordable prices, I will drop the link to their website in video's description, and you will also get a coupon code of 50% discount on a range of GPUs. Just check my video's description and you should be able to use both of them. Okay, so let's create a virtual environment again with Conda as we always do. And now let me install this RAGChecker. I'm also installing OpenAI with it. Let's wait for it to get installed. It's very lightweight actually. And RAGChecker is installed now. Now let's download our a small English language model which is called as an Core Web SM. That is the requirement of this, and we are downloading it with Spacey, which is a modern NLP or natural language library for Python that focuses on natural language understanding. So let me run it. It is a very small size, I believe just 50 MB or okay, no, it is 12 MB. That okay, that is interesting. Anyway, so it is done. Now, once that's done, we would need to export our OpenAI's API key in the environment, something like not this. I'll just paste it here. Export OpenAI underscore API underscore key. So let me paste my OpenAI's API key here, and you would need to get it from platform.openai.com. That is a paid option. So let me paste my key here and clear the screen. And now let's git clone the repo of RAGChecker, and we are seeding into it. That is also done. Now let me open it in the VS Code editor because I need to show you the code where we will be using this RAGChecker and also a sample input data which is coming through the RAG pipeline. So this is our RAGChecker repo. You can also use it with CLI, but I'm just going to create a simple Python program. I'll just call it test.py. You can call it anything you like. And I think I created it in the wrong directory. So I'm just going to delete it from here. And I'm just going to click here. And then let's create the test.py here at the root of the repo. And let me paste it. Now all I am doing here is I am just importing the RAGChecker, and then these are the extractor and checker. RefChecker is something which I will be covering in another video. And then you can either set the OpenAI's API key in the file or in the environment. I already have set it in the environment. And then I'm specifying the GPT-4o model, and these are the extractor and checker. So this extractor, this extracts the data and this checks the data. That's all it is happening. And this is interesting bit where they have given an example. So it's an input file in the JSON format which it is extracting and checking. So this is evaluator which combines extractor, checker, and then evaluates it on the basis of the matrices which I showed you earlier, and then prints the result. So if you go to the examples directory, check this input file, you will see it contains some of the data around query number 0. The query is what's the longest river in the world, and then this is a ground truth answer, and this is a response, and then this is a retrieve context around it. So this checks it whether it is for all the matrices, whether your rack, whenever a user asks this query, and this is a context if the answer is faithful, if it meets the noise or not, if it is hallucinating or not. So all those things. Okay, you can either run it with this shell script, but I'm just going to run it from my local system. I'll just use the test.py from the terminal. So let me go back here. We need to save this file, and then let's go to the terminal and let's clear the screen and run it. So I'm going to run it from the command line. You can see python test.py. Let's wait it to print out the results after checking the data. It is running, it is checking all the results. And then, so these are all the evaluation matrices it is checking. You see that claims and all that stuff, retrieve to answer. There you go. And there are our total overall results. So this output is showing that the evaluation matrices for all this RAG from the RAGChecker. For instance, if you read through them, The precision is quite good, that out of all the claims made by the model, this percentage of them are correct. Then we have recall, which is around 77%, you can say. And this means that out of all the correct claims that should have been made, the model made 77.5% of 73.8% of them. And then F1 score is around 68. This is a harmonic mean of precision and recall, providing a balanced measure of overall performance. And if you look at retriever matrices, the claim recall is 66.7%. This means that the retriever was able to recall 67.5% of the correct claims from the knowledge base. Context precision is 100%. This means that all the retrieved chunks were relevant to the query. And then we have generator matrices, where you can see context utilization is 85.7%. That means that the generator was able to utilize 85.7% of the relevant information retrieved from the knowledge base. Noise sensitivity in relevant is 18.1. That means that the generator was sensitive to this much of the noise present in the relevant retrieved chunks. And then it wasn't really, generator was not sensitive because it is 0.0 to any noise in the irrelevant retrieve context. Hallucination is 11.8. This means that the generator produced 11.8% of claims that were not present in the retrieve chunk. So look, even if you can get this much information around hallucination, that is a big win if you are doing real critical RAG there. So you know that um, your retriever, when it retrieved the similarity search or whatever from your vector store, it was not able to produce the 100% correct results. There were still 11.8% hallucinations. That is very important thing. And then self knowledge is 5.6. This means that the generator relied on its own knowledge to produce 5.6% of the correct claims because it was not in the context. Faithfulness is 82.6, which is quite high, and it means that generator was faithful to the provided context for 82.6% of the claims. So if you really think about it, I think it is quite useful. So I will drop the link to it in video's description. Let me know what you think about it. If you like the content, please consider subscribing to the channel. If you are already subscribed, please do me a favor and share it among your network, as it helps a lot. Thank you for watching.